Welcome to the Verint Fusion Center, known as the IFC. The IFC is a single-point intelligence environment for data fusion, collaboration and insight generation, helping to fight terror, crime and financial fraud, while serving investigators in law enforcement and security organizations. In this demonstration, we'll review the general intelligence functionalities and workflows in the system and show how they promote our intelligence investigation goals. The demo is describing a criminal investigation in Brazil. Let's open the investigation dashboard, where we see an ongoing investigation regarding a terror threat in Brazil. The work area includes a toolbar of action options, the search area, the locations map, a results area, and investigation facets. The facets are statistical data widgets, generated automatically and dynamically on the results of your current search. In our investigation, for example, we have about 100,000 results. The facets display statistics regarding the investigation, types of content, types of entities, languages, countries, the offense type, and more. Let's begin by running a simple search, similar to Google search, using fuzzy logic. We're searching for information on a mobile phone starting with the prefix 556. The result is 5,000 relevant records with highlighted indicators. We can see the facets that are generated for this result set. We'd like to focus on the call data records. We can use any facet attribute as a filter to slice and dice the results. Let's click on the CDRs and see that there are two types available, calls and text messages. We're interested in seeing more information on phone calls, so we click on the calls bar. And we want to add a filter on the map and define Brasilia, which is our area of interest. We can see that 136 results were found, matching our filters of the prefix 556, CDR data type, call entity, and geographic filter. So you see how simple it is to search and drill down into the data. Now let's run an advanced search and see that the system provides autocomplete options for the entry. We're searching for information related to car bomb events. The system presents the results and automatically generates the facet statistics. Using the facets, we discover the persons related to these results. We have several additional search options that we could use. In the Google-like search we saw before, we can add a fuzziness level, expanding the search to include names with similar sounds but different spelling, and adding more options to our results. Another type of search is called assisted search or structured search, where we can easily search on different attributes of any data source by defining a Boolean expression with several conditions for the search. We could have also used a wildcard or semantic search. The most advanced type of search we will see in this demonstration is the group search, which provides the next step in the investigation by finding only the related persons in the results. The color-coded links indicate the type of connection between the entities: police logs, communication link, and family link. Any search can be saved for future use in the system and can be saved as a rule for an alert, assuring investigators are alerted to any instance that complies with the search parameters. Another important option for knowledge discovery is the alerts view. One of the first actions the analyst performs is reviewing his latest alerts, in this case from an investigation on the Jardim Sul theft. Drilling into one of the alerts shows the alert details, the original rule for the alert, in this case track target location, we see its urgency, and the main entity details. We can also see that the location's source entity is a Skylock entity, Verint Cloud Location Solution. When there's a location, we can view it on the map. After seeing the data discovery capabilities, let's have a look at the person's profile. The profile incorporates all the details known about him. This is a snapshot of all available data regarding this entity within a consolidated folder-like view. On the left, the description summary presents high-level attributes: the person's criminal history, relationship with criminal organizations, and involvement in other investigations. At the top, the information tabs present different aspects of his profile. In the About tab, we can find his general characteristics, such as ID number, gender, nationality, and date of birth. physical characteristics which would serve field units in case of a future arrest, contact details such as phone number, online web accounts and email addresses, known places he visited such as his home location and his work location. Just one click and the investigator gets a full profile that provides a comprehensive view of the suspect and his background. Let's see what we can learn about Gustavo Ferreira from his profile. In the General Information tab, you can find additional information such as weapons he owns or real estate assets. Here we see Mr. Ferreira owns 2 properties, a home and a warehouse. In the Activity tab, we discover the aggregation of his activities. The map exposes where the activities took place regardless of the data source, cellular locations, Twitter GPS tagging, police records or surveillance cameras. Another view option is the Routines tab, applying routine calculations on top of the system data. In this view, we present a weekly calendar of the person's routines, which are color-coded according to type of activity. The system highlights the fact that most of his activities are not performed from his registered home address, but from another location. These intelligence insights are made possible by the automated mapping and processing of data. Let's look now at Mr. Ferreira's human relations map, which presents the complete network of the subject, his relations and associations. We can see different entities related to him, a weapon, a vehicle, criminal history file, and his credit card. This display mode includes many different functions. We can change the visual display into a list display. This display allows us to sort and to group the information in different ways, for example by entity type, showing there are 5 phones, 14 persons, 3 police records, 2 HUMINT reports. For each of these we can expand the map for further information. Let's return to the visual mode. The system supports different types of visual displays such as hierarchic view or radial view, emphasizing the data from a different angle. The group and filter function allows the user to highlight different aspects of the data according to any parameter. Another display factor is the link strength. The width indicates the number of instances for that link. A one-time call may be less interesting or may indicate a new link. The link color represents the type of activity. Blue line signifies communication link, and the green line represents a family link. The user can decide to filter according to the link strength and display only relations with strong strength. Now let's locate Robert on the link map. In the right pane, we can see detailed information for each entity: persons, police reports, phone numbers, etc. We can easily expand our knowledge regarding the displayed entities by selecting an entity, for example Robert, and expand his relations to display new entities related to him, in this case police logs and vehicles he owns. We can also add information to share with other users by attaching a note to an entity. For example, for this person we enter, "This person should be watched." From the link analysis graph we also learn that our suspect is related to Mr. Silva, who's a known criminal. We can send a direct request to start monitoring his communications. The monitoring center will start tapping Mr. Silva's phone according to the details we send him from the IFC. IFC is built for the investigator from the ground up, and you can see how easily it interfaces with additional law enforcement environments. Taking a look at the details of Mr. Silva, we discover he's using a fake name on his web profile in the name of William Martins. This seems suspicious, so we check further into the account. We expand the account and discover it is related to 2 other web accounts. One of the accounts, in the name of Jennifer Hogue, is more active, so we focus on it and learn more from the information pane. Communication content retrieved from tweets such as, "I think we should meet," "Let's meet at Starbucks," "Seems like a great place," indicates Silva and Jennifer are planning to meet. We expand this web account and check to whom it belongs. The account details lead us to an entity in the system known as Diego Enriquez. This is yet another person using a Facebook account with a fake name, and this again seems suspicious. Diego Enriquez is connected to Mr. Silva through 2 other police cases, in which both suspects are being investigated. To look at this from another angle, we can replay Mr. Silver's relations timeline and understand the history of this relationship. To summarize, thanks to the Fusion Center's link analysis, we've linked our car bomb suspect with a known criminal, started communications tapping, and have raised the prioritization level regarding these entities. At this point, we can take a look at another case in which we've enriched our data with call data records, CDRs, and cell locations added from tactical solutions such as Cloud Location Solution, Skylock, and Cellular Network Intelligence, GI2. We can see the facets in this investigation, indicating CDRs from GI2 and Skylock locations. On the map, we see the entities derived from the Skylock locations. Putting our investigation capabilities aside for the moment, I'd like to invite you backstage to see how the administrator uses IFC to connect and manage the various data sources. Let's see which data sources we have in our demo environment. We can see the phone book registry, vehicle registry, telephony call data records, and financial records. But you can load any data file from any source, either structured or unstructured data, as we currently support more than 100 database formats and 500 file formats. To edit a new data source, you simply enter a name for the source and determine the technical configuration, such as the parsing format for the source content, and the security mechanisms, separate networks from internet, subnets, antivirus scanning, firewall setup, and intrusion protection systems, user authentication, and more. These assure that no malicious data enters the system. We then map the fields of the incoming content to the system structure. This is part of the normalization or ingestion process. The system automatically maps the fields of the source data and enables your administrator to assign destination fields in the system database schema. We now determine the ingestion type and normalization processes for the incoming content. And we set the collection scheduling policy, deciding when to run the first upload and subsequent incremental updates. At this point, we've defined the new source type and its management policy. An important aspect of data fusion is the data entity model. This determines how each data component is defined and managed within the Fusion system. Entities can apply to person, event, organization, group, vehicle, weapon, and many others. Our aim is to match each data component to an entity and present it as a fused intelligence entity. Here we can see a high level of definition of the data model and the interconnections between the entities. Let's look at the ingestion layer. The ingestion layer is the normalization layer, where the data integrator decides what type of processing to apply to the incoming content. Ingestion is applied to text, video, images, unstructured data, and structured data, and determines which normalization actions should be applied to each type of content, allowing the system to later present it simply and intuitively to the investigator. The processing enrichment and data merging policies applied at the ingestion stage assure higher quality data for the investigator. Let's look at one example for the file ingestion flow. We can see the ingestion definition for a PDF file. Every step is defined, such as how to access the file, text extraction from image using OCR, translation, or entity extraction. There are many options, and they are easily customized per data component. The entity modeling and data ingestion steps are a moment of magic when data is converted into intelligence. The system's health monitor allows the administrator to monitor all system components, functionality and performance from a single centralized intuitive interface with out-of-the-box monitoring and alert tools. Administrators can review the system's physical status, such as storage availability and CPU usage. They can also check the logical status of the ingestion mechanisms, enrichment and analysis engines, and external interfaces. Alerts on system failures or problems are sent in real time to the administrators, allowing for immediate troubleshooting and handling. In this demonstration, we covered several scenarios and functions of the Verint Fusion Center. We've seen the investigation dashboard with built-in intelligence flows. We've worked through simple search, filtering by use of facets, geographic filters, advanced search, person profile, visual link analysis, including a range of investigation capabilities, and system recommendations related to group search, as well as relationships between two targets. We've also seen the simple and effective data management and health monitoring functionalities the system offers, allowing you to start off at a small scale and add sources on the go. Thank you for being with us. We are happy to answer any question and further present the benefits of the Verint Fusion Center for your organization.